Hello. Last class we looked at the square root property, and when we used the square root property we needed an equation in the form something squared equals a constant so that we could use it. What I want to do now is I want to look at another example that's going to look a little bit different, but it's still going to satisfy the square root property. Let's solve x squared minus 6x plus 9 equals 2. This might not look like something squared equals a constant. However, this is a perfect trinomial square. If we factor this, it is a special form. Note that x squared is x squared. 9 is 3 squared. If we take the product, x times 3 gives us 3x, and if you double it, you get 6x. So this actually can be factored as x minus 3 squared. You could also use unfoiling to get this, but I wanted to remind you of that special form, because today our goal is to get things into this special form, because then we can factor it as something squared equals a number, and we can use the square root property. Let's finish this problem, and then we'll talk about how we can get things into this form. So when we take the square root of both sides, we're left with x minus 3 on the left. On the right, we've got plus or minus root 2. And then to get x alone, we add 3 to both sides. This gives us x equals 3 plus or minus the square root of 2. Now, moving forward, we are not always going to have things that are already in this form. In fact, we're not already going to have things that are in this form. What we're going to have is we're going to end up having the first two terms, like x squared minus 6x, and we're going to need to figure out what number to put here so that it becomes a perfect square trinomial, and we can factor it as a perfect square and then use the square root property. So I want to take a look at a few examples because this will help us to see a pattern. Let's consider the following. X squared minus 10x plus 25. This is a perfect trinomial square. It's x minus 5 squared. Then n squared plus 2n plus 1. This is a perfect square trinomial. It's n plus 1 squared when we factor it. And I want to look at y squared minus 14y plus 49. This factors into y minus 7 squared. So we have 3 examples of perfect square trinomials. And what's going to happen is we're going to be given problems where we are given the first 2 terms, and we need to figure out what constant we can add at the end to turn it into a perfect square trinomial. And there's a nice pattern here that we're going to be able to rely on to come up with a rule. Now in each of these examples, we have one piece of information that we're starting with. We have the coefficient on the x, or the n, or the y. And we need to, like a detective, figure out how these 3 things can change into these 3. So what can we do to negative 10 to turn it into 25? That will also turn 2 into 1, and it'll turn negative 14 into 49. Well, we can take this number, divide it by 2, and then square it. So we divide by 2, then square. Let's make sure that this works. Negative 10 divided by 2 is negative 5, and when we square negative 5, we get positive 25, so that's good. If we take 2 and divide it by 2, we get 1, and then we square it, we end up with 1. And if we take negative 14 and divide it by 2, we get negative 7, and when we square that, we get 49. So this is the strategy here. We take the coefficient on the variable, divide it by 2, and square it. And we can write this out as an algebraic rule. If x squared plus bx, some number times x, is a binomial, then we can build a perfect square trinomial by adding, what do we add again? We take this coefficient, which is b, we divide it by 2, so that's b over 2, and then we square the result. So specifically, we end up with x squared plus bx plus b over 2 squared. And when we factor this, this ends up factoring into x plus b over 2 quantity squared. Now you might be confused as to why there are fractions here and there weren't any fractions in the example here. Well, in all of these examples, the value of b was even, and when we take an even number and divide it by 2, we end up with an integer still. However, to say that we take a generic quantity b and divide it by 2, we have to write it as b over 2. So in the rule, we have to write it as a fraction to denote that we're dividing by 2, but that doesn't mean we will always end up with fractional answers. Let's use this to complete the square for a couple of examples, and then you can do some more in the linked videos below. So let's complete the square, then factor. The first example I want to look at is y squared plus 8y. This is our original problem, and we need to figure out what quantity we can add to end up with a perfect square trinomial. Well, the rule says take the coefficient on the variable, in this case that's 8, divide it by 2, 8 divided by 2 gives us 4, and then we square it, and 4 squared is 16. So the thing that we need to add here to make it a perfect square trinomial is 16. Then when we factor this, it ends up being y plus 4 squared, because y squared gives us y squared, and 4 squared gives us 16. The number that goes here is always going to be what we get after we've divided by 2. 8 divided by 2 gives us 4. Let's do 2 more. Let's look at x squared minus 6x. Now we need to figure out what we can add to this to turn it into a perfect square trinomial. So we're going to follow the rule. Negative 6 divided by 2 is negative 3. And then when we square negative 3, we end up with positive 9. So adding 9 gives us our perfect square trinomial. And if we factor this, this becomes x minus 3 squared. It's going to be negative 3 because that's when we get after we take negative 6 and divide it by 2. Let's do one more. Let's look at x squared plus 3x. Again, we're looking to see what we can add to turn this into a perfect square trinomial. To figure that out, we need to take the coefficient on the x, divide by 2, and square it. 3 divided by 2 is 3 halves, a fraction now, and if we square that, we need to multiply it by itself. 3 halves times 3 halves is 9 fourths. So we end up with 9 fourths being the thing we need to add to complete the square. If we have an odd number here, then dividing by 2 leaves us with a fraction. Now we will factor this. This becomes x plus what squared? Well, after we took this 3 and divided it by 2, we get 3 halves. And so it's going to be x plus 3 halves squared.